In this video, we'll be going over two example problems involving the collection of gas above water. Let's start with the first one. We're given the reaction of zinc reacting with hydrochloric acid, and this is the balanced chemical reaction. If 520 milliliters of the hydrogen gas, you can see that hydrogen gas is produced, was collected over water at 28 degrees Celsius, and the atmosphere is 1 atm, how many grams of zinc was used in the beginning of the reaction? So we're given the final volume of H2 that's produced, and we have to determine the number of grams of zinc that's produced, or that was reacted. Let's start with just a picture. So here's a picture I found online, and I modify a little bit. We have zinc that is reacting with the hydrochloric acid in a flask, and then it's going to produce hydrogen gas, and the gas is going to flow through this tube, and it's going to get collected above the water, hence the term named collection of gas above water. So we're given the volume of the gas. It's 520 milliliters. We're also given the pressure, the atmospheric pressure. So it tells us that the pressure on the outside is 1 atm. That's also going to be the pressure of what's in the inside. So we know that the total pressure is 1 atm, but this is the total pressure. There's actually two gases above the water. There's the H2 that's reducing, but there's also water because there's water here, so some of the water is going to evaporate. So we have a mixture of gas above the water. We have the H2 and we have the water. So we know that the total pressure is 1 atm. Well, the way that we're going to approach this is we're going to figure out the moles of H2 and then use stoichiometry to convert that to moles of zinc and then to grams of zinc. But to figure out the moles of H2, we first have to figure out just the pressure of H2. We don't want the total pressure, we want the partial pressure of H2. So the way to get the partial pressure of H2 is to take the total pressure and subtract the pressure of the H2O. In this problem, we're given that the pressure of H2O is 28.3 millimeters of mercury. Let's convert that to atm because we are given that the total pressure is 1 atm. So we'll do that on the side right here, 1 atm, and to convert atms to, well, actually, sorry, got that mixed up. We're going to convert the 28.3 mmHg into atm. So we'll just multiply by the conversion factor. There's 1 atm in every 760 millimeters of mercury. So we'll just do 28 divided by 760 and see what that gives us. 20.3 divided by 760, that gives us 0.0372 atm. So now we're going to take the total pressure, 1 atmosphere, minus the partial pressure of the water, 0.0372 atmosphere, and that'll give us the partial pressure of the H2, which is 0.9628 atm. Now that we have the partial pressure of the gas, let's figure out the moles of the gas, and to do that, we're going to use PV equals nRT. Since we're trying to solve for the moles, which is n, so we're going to divide both sides by RT. So we'll get n equals PV divided by RT. P is the pressure of the gas, which we just solved for, 0.9628 atm. V is the volume of the gas. The volume has to be in liters, so we'll take the 520 divided by 1,000 to get into liters, and it'll give us 0.520 liters. R is just the gas constant, 0.08206, and then T is the temperature, and that has to be in degrees Kelvin. So we'll take 28 plus 273 to get the degrees Kelvin, which is 301. Then plug this into a calculator, and let's see what the moles is going to equal. That gives us 0.203 moles of the zinc, or actually not the zinc, but of the gas, the H2 gas. So now we have moles of H2. We want to figure out the grams of zinc, so we're going to just do a mole conversion and then a gram conversion. Let's start with the moles of H2. We'll convert it to the moles of zinc. So that's why we use the mole-to-mole ratio. And you can see this is a 1:1 ratio. So we'll put 1 mole of zinc on the top and 1 mole of H2 on the bottom. And we're doing this so then the moles of H2 can cancel out. Now that we have moles of zinc, the last step is we just have to convert it to grams of zinc by using the molar mass. And here you can see that the molar mass of zinc is 65.38. So we're going to multiply this by 65.38 grams of zinc for every 1 mole of zinc, since molar mass is how many grams there are in 1 mole. And this will cancel out the moles of zinc, leaving us with just grams of zinc. So we'll do 0.0203 times 65.38, leaving us with a final answer of 1.33 grams of zinc. So that's the final answer. Just to recap what we did, we started with the total pressure, and then we subtract the partial pressure of the H2O. The problem gave us the vapor pressure of water, so that's just the pressure of the water, and that gives us the partial pressure of the gas. Once we have the partial pressure of the gas, we use ideal gas law to solve for the moles of the gas, and then we use stoichiometry to figure out the grams of the reactant. All right, let's take a look at another problem. I think the next one will cement this idea better. Okay, this next problem is very similar. We're given that a piece of sodium metal undergoes the following reaction with water. The hydrogen gas is collected over H2 at 25 degrees Celsius. The volume of the gas that's collected is 2.46 millimeters, measured at 1 atm, and then we have to calculate the moles of the sodium that's used. So we're given the volume, and then we have to calculate the moles. Very, very similar to the previous problem. Just like the previous problem, we're going to start by just calculating the pressure of the gas that we're collecting, so we can eventually get the moles and then use stoichiometry. So the pressure of H2 is going to equal the total pressure minus the pressure of the H2O, and the total pressure tells us 1 atm, and the partial pressure of water, it tells us right here, vapor pressure of water is 0.313 atm. That gives us 0.9687 atm. Now that we have the partial pressure of H2, we'll be using the ideal gas law. So we'll use the equation N equals PV divided by RT to solve for the moles of the hydrogen. And so we'll use the pressure of the hydrogen, 0.0313 atm, the volume of the hydrogen, which is 246 milliliters, but we got to get that into liters, so just divide this by 1,000, 0.246 liters. R is the ideal gas constant, 0.08206, and the temperature, adding 273 to this, gets us 298 degrees Kelvin. That's 0.000315 moles of the hydrogen. Then we can just convert moles of hydrogen into moles of sodium by using the mole-to-mole ratio. So 0.000315 moles of H2 multiplied by, it's going to be a 1:2 ratio. So 2 moles of H2, 2 moles of sodium on top, and 1 mole of H2 on the bottom. So then the H2s can't cancel out. And that leaves us with 0.00062,630 moles of sodium that was used. Collection of gases above water is pretty similar to just gas stoichiometry. The only thing extra that you really have to do is when you are using the ideal gas law, make sure you're just using the pressure of the gas that you're collecting. And to do that, you just take the total pressure, subtract the pressure of the water. If you want to learn how to ace chemistry, if you want to learn what's the best way to study for this class, if you want to learn some neat tricks and tips to take into your exam and do better on them, then you should head over to my website and get this free guide, 12 Secrets to Acing Chemistry. You can head over to www.conquerchemistry.com/chemsecrets. I'm going to include a link in the description below. Check it out. I think it's really going to help you, and you're gonna like it. Until next time, keep working hard and continue the good work.